In this video for section 4.1, we're going to talk about compound interest formulas. Compound interest is when earned interest is periodically added to the principal. So you're earning interest not only on your principal amount invested, but also on the previously accrued interest. So we have some different time periods here. We could add interest back to principal twice a year, which we say is compounded semi-annually. Every 3 months or 4 times a year would be compounded quarterly, and we could also compound interest monthly, which means 12 times a year, or daily. Another possibility is that we could compound the interest continuously, which means that the number of conversion periods per year is infinite. So basically, as soon as interest is earned, it's put back into the principal so it can earn more interest. And it sounds like this is going to make you a lot more money, but in reality, compounding continuously is not very different from daily compounding. So we have the two formulas here. Our variables here are T is the time in years, A is the balance in the account, P is the principal, and they used the wrong principal here, it should be PLE, and R is the annual interest rate, which we need to convert to a decimal. For n compounding periods per year, we use this first formula, and for continuous compounding, we use the second formula. Notice that the continuous compounding formula uses E, and remember, E is not a variable. You would use the E button on your calculator for that. So we're going to look at example 7 from the textbook. It says that you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year compounded monthly, and the second pays 6.85% per year compounded continuously. Which is the better investment? So I'm going to identify some of my variables here. The amount that I'm investing, $8,000, is my principal P, and the time is 6 years. And for my first account, my first option, I'm paying 7% per year, so I need to convert that to a decimal. That would be 0.07. Move the decimal point 2 places or divide by 100. And compounded monthly means that n equals 12, because if it's happening monthly, it's happening 12 times a year. So now I'm going to plug in. So A equals 8,000 times 1 plus 0.07 over 12, and then raised to the 12 times 6 power. Note that the n appears in 2 places in the formula. So now I would type this all into my calculator at once, ideally. If not, what you would have to do is multiply 6 times 12 first, then you would have to do this calculation, raise it to the 72nd power because that's what 12 times 6 is, and finally multiply the answer by 8,000. It's much easier if you can just type it in all at once, and that will give you a value of $12,160.84. Now for my second option, I have an interest rate of 6.85% per year. Now sometimes people have trouble with interest rates when they have a decimal in them, but moving the decimal point 2 places would give me R equals 0.0685, and it's compounded continuously, which means I don't have a value of n, I'm using the second formula. So A equals, plug in 8,000 for P, and then E raised to the power of 0.0685 times T, which is 6. So again, if you're doing this in like an iPhone calculator, you would multiply 0.0685 times 6 first, then do e to that power, and lastly multiply by 8,000. If you're doing it on a better calculator, you can get the answer directly of $12,066.60. So which is the better investment? Well, the one with the larger return is investment number 1, so I would choose that. So even though it's compounded monthly instead of continuously, having a slightly higher interest rate means that you earn more money. So next you should look at checkpoint problem number 7. Do this in your notes, check your answer, and then go on to the homework.